What's going on, guys? Mr. Jones coming at you once again. I'm going to try and make a quick video today. So we'll see how that works out. We're going to do Ready, Set, Go 3.7. So we just did task 3.7. It was a practice task. So now we're going to do some more practice. Here we go. I'm going to read the directions and then we'll kind of talk about it. The given functions provide the connections between possible areas, A of x, that can be created by a rectangle for a given side length x and a set amount of perimeter. Wow, that sounds like a long, daunting sentence, doesn't it? You could think of it as the different amounts of area you could close in with a given amount of fencing as long as you always create a rectangular enclosure. All right, so this is all in a gist, just trying to say that we're going to give you the area of a rectangle, and we're going to try and figure some stuff out. So let's actually just look at this first one together. Here we go. Let's do this. Let my whiteboard pop up and see how it goes. All right, here we go. So all the problems are all for the same concept. It wants you to look at it saying the area is the side length base times height, right? So if you drew some rectangle, right? If one side's x, the other side is 10 minus x. So obviously this x and this x are the same, right? So just to give you an example, if it said a of 3, let's do it one that isn't there. So we'll do a of 2. A of 2 equals. That means that all the x's are 2. So you're going to plug in 2 here and you're going to plug in 2 here. So you're going to get 2 times 10 minus 2, right? 2 times 10 minus 2. Well, 10 minus 2 is 8. So 2 times 8 equals 16. So a of 2 equals 16. Okay, so that would mean that the side length here was 2 and the side length here was 8, and that's your rectangle, right? Okay, so now if I erase those, that's just what it wants you to think about. Then, so now you're going to do a of 3, a of 4, a of 6. So basically plugging in different values for x and solving. And then it says, what if a of x equals 0? Okay, what if a of x equals 0? That means you plug in 0 right there and you solve. So you say 0 equals x times 10 minus x. Okay, if you're factoring, and a lot of you guys saw this using the photo math, okay, if you set this equal to 0, you can make you need this entire side right here to equal 0. But if you just set only this equal to 0, 0 times anything is 0. Okay, so you can say x equals 0, or if you set this equal to 0, 10 minus x equals 0. And now you can just solve for this. So how do you solve for this? Well, subtract 10 from both sides, right? Just go ahead and get x by itself. Subtract 10 from both sides, and you get negative x equals negative 10. And then you just multiply both of those by negative 1, or just realize if they're both negative, the trick is you can make them both positive. So x equals 10. So now you have two answers, 0 and 10. But the trick is you had to plug in 0 for the f of x on that one. Now, another way you can probably think about this is you can do a bunch of different methods. That was just one. But if you know it's this, okay, you can always multiply this out and then see what you get. 0 equals 10x. Right, minus x squared. And so if I was to rewrite that, 0 equals negative x squared plus 10x. Now, this number, by the way, is plus 0. You can add 0 and it changes nothing. Now you have a standard form quadratic. And if it's factorable, you can factor it. If it's, you can use the quadratic formula, all kinds of different methods. The point is on each one, how do you know which value of x will give you the biggest answer? So you're going to get an answer for A, B, and C, and then which value was always going to give you the biggest answer. All right, moving on to the set portion, it just says for each of the given quadratic equations, find the solution using an efficient method. So use whatever method you want. Okay, remember that number 5 is already a standard form that equals 0. Number 10, for example, you have to subtract 7 from both sides so you can make it equal to 0. Okay, my suggestion is if you can factor it, go for it. If you can't factor it, then use quadratic formula. Okay. And then number 11, 12, and 13, summarize the process for solving a quadratic by the indicated strategy. Go ahead and just cross off number 11, completing the square. You're just going to do 12 and 13. Those are the ones we're working on. It says summarize the process. So basically, in your own words, in complete sentences, type it if you want. Tell me the process for factoring and the process for using quadratic formula. And it says also indicate when it is best to use this strategy. So I should see a few sentences for number 12 and a few for 13, right? All right, next, the go section. That's always just some review stuff. It says graph the quadratic function and supply the information. So you should be able to graph this. Okay, it wants x-intercepts, y-intercepts, vertex, and axis of symmetry. So check your work with Desmos. But 14 and 15, you should be able to graph those. If you have to factor them, see where the x-intercepts are, you guys should have the skills at this point to graph them. All right, 16 through 19, just go ahead and cross off number 16. 17, 18, and 19, basically it says they're systems of equations, so there are two going on at the same time. They both have to be true at the exact same time. On number 17, for example, if you have two equations that equal y, okay, if they both equal y, then guess what that means? It means they both equal each other. So you're going to rewrite this, okay? And you're going to solve for x now. And you're going to tell me what x equals, and then you're going to also tell me what y equals. Okay, so once you get the answer for x, you're going to plug it back into one of the equations, and then you're going to solve for y. So that's what you do for 17, 18, and 19. If you're more confused about that, either ask me or you can look up solving systems using substitution. Solving systems of equations, just like it says over here, systems of equations using substitution. And then you'll learn how to do it that way. All right, guys, that's all I got for today. Hope you guys have a great rest of your day. And I'll talk to you guys later. Bye.